If you crossed paths with this bird, your first instinct might be it stepped out of a gothic fantasy novel. This is the Ayam Cemani. That ink-like tone penetrates deep past the feathers. The beak, the skin, and even the tongue carry that exact same charcoal hue. But the true shock comes when you look inside. Peel back the skin and you won't find the typical pink tissue of a common bird. The meat, the heart, and all the internal organs are pitch black. Every inch of this animal seems thoroughly dyed in shadow, creating the compelling illusion of an extraterrestrial creature rather than a standard farm bird. In biology, there are strict rules about where pigment belongs. For the vast majority of animals, melanin, the compound responsible for dark coloring, is assigned securely to the exterior surface, coloring skin, fur, or feathers. Looking at this vintage illustration of standard avian anatomy, the internal structures are totally devoid of pigment. The Ayam Cemani invores this baseline entirely. The dark tissue goes deeper than the muscles and organs. In this bird, the pigmentation pushes through the anatomy, staining the entire skeleton solid black. We are left with a biological mystery. What mechanism is capable of overriding these anatomical boundaries and dyeing an animal right down to its bones? You might assume a creature this unusual is an alien species. But if you look at its DNA, the Ayam Cemani is a common chicken, harboring a highly specific genetic mutation. That mutation is called fibromelanosis. It acts as a biological glitch that forces the animal's body to hyperactivate its natural melanin production. This microscopic view shows how heavily stained biological cells can become. Normally, a cell regulates its pigment levels. Inside the Ayam Cemani, that off switch fails, resulting in a relentless cellular overproduction of melanin. A single microscopic error in the genetic code converts a normal avian body into an unstoppable melanin factory. This diagram illustrates what happens when that factory goes into overdrive. The body generates a massive excess of melanin, exceeding the storage capacity of the skin and feathers and spilling past the barrier. With the primary storage full, those dark particles have nowhere else to go. They flood directly into the internal vascular and tissue networks. That internal flood essentially acts as an organic dye, soaking the muscles, flooding the organs, and eventually the bones from the inside out. The bird's entire internal biology is effectively hijacked by a single pigment, systematically breaking all standard rules of anatomical color. When a mutation is aggressive enough to dye a heart and a skeleton black, the logical assumption is that every fluid and byproduct inside the animal must share that same inky color. But the chicken's blood is not black. It remains bright, standard red, and the eggs it lays aren't black either. They emerge with a completely normal cream-colored shell, totally untouched by the internal flooding. For all of its pervasive physical transformation, the fibromelanosis mutation hits a set of strict, invisible biological limits. This shows why. Blood color is driven by hemoglobin on a separate biological pathway, so melanin simply cannot bind to it. A similar block happens with eggs. Shells form through an isolated calcification process, diverting the melanin flood away. The Ayam Cemani reveals how a genetic instruction can overhaul a skeleton while leaving the blood flowing around it entirely untouched. Underneath the black meat, the black organs, and the black bones, these unchangeable biological boundaries prove it is still a standard chicken.